GMGM, and welcome to the Self workshop. So today we are going to see how you can, using Self, generate ZK proofs about your identity, like the fact that you are 18 plus, the fact that you are part or not part of a specific countries, and each time without having to reveal anything else. And the best is that you can verify these proofs, because these are ZK proofs. You can verify them on-chain or off-chain. And the implementation is actually extremely simple. We have a bunch of SDKs that are available. So we are going to see all of this together. All right, but first, the plan about today is pretty simple. So in the first time, I would like to give a bit more context about the protocol. Then we can chat about the bounties, because maybe you are here because you are sponsoring the ETH Global Hackathon. And finally, I think that the best is to get our hands dirty and just learn by doing, and yeah, code with examples. So let's say that you're an application that needs to verify the identity of your users, and you need to do this on-chain or just online, So currently the fallback solution is the well-known and overused KYC process, which is pretty bad for many reasons. First, it's not private, meaning that you are going to share all your information with the third-party application. It's also not really secure. Now using generative AI, it's extremely simple to pass this KYC process. And last time, I think it was 2 weeks ago, I saw something like for $15 on the dark web, you can pay to pass this KYC process. So even from the application perspective, it's definitely not secure. And finally, the user experience is pretty bad. Each time, user will have to find the ID document, scan it, send for verification, and then wait until the verification occurs. So if you're an application, you are going to experience a lot of drop-off here. Alternative to the KYC by building a decentralized identity, but to these dates, it's quite hard to find something that is really convincing. The general proof of personhood used to be quite popular before, like proof of humanity, in which you hold a sheet of paper in front of your camera with your address written on it, and ID now, where you used to solve CAPTCHAs to prove that you are a real human. But unfortunately, we could expect within a few years AI to be able to solve CAPTCHAs that human can't. Then you have the biometric proof of personhood. So these ones are super interesting because they are private, like Word, for example. But some people can be reluctant to scan their eyeball, obviously. And because it's hardware-based solution, it has the drawbacks of hardware, meaning that you could put a barcode inside, or you could also trick somehow the sensors. Finally, you have all the social graphs-based solutions that are cool because they are fully decentralized, but unfortunately still gameable. So that's why a few years ago we decided to build Self by leveraging the most trusted attestation of who you are, aka the biometric passport. So the paradigm of Self is quite different. Instead of building everything from scratch, the idea is, all right, let's just piggyback on the existing ID infrastructures that are in the wild, and let's hijack them using ZK. So biometric passports are a pretty good fit for that because they are quite hard to obtain and unique to individuals. Most of the time, people only own one passport. Maybe you have two because you have a dual citizenship, but it's still quite scarce. And yeah, if that's the case for you, you are extremely lucky. Also, they are pretty secure in a way that also people have this intuition that a passport is something pretty that you should take care of. And finally, and most of all, they are machine readable. meaning that using the camera, you can scan the machine readable zone of the passport, for example, on the main page. But there is also in biometric passport a chip that you can read using the NFC reader of the phone. And this chip contains most of the passport data, but also the digital signature of the document, meaning that you can verify this digital signature inside the zero knowledge proof. And by doing so, you can already mitigate most of the issues related to identity, such as prove that you're a real human. I'm a real human because I own a biometric passport, a biometric ID, something like that. You can also prove random stuff about you, like the fact that you're 18 plus, the fact that you are not part of the offchain sanction list, and each time you don't have to reveal anything else. So that's pretty powerful. So here is the list of what you can already prove using Self. So you can prove that you are part of a specific country, that you are not part of a country list, which is pretty good for compliance. You can prove that you are above a certain age, that you are 18 plus, that you are not part of the OFAC sanction list. You can reveal stuff about you. You can reveal your name. You can reveal your birth dates. You can reveal, unfortunately, not your hair color, but soon you will be able to do so because it's inside the picture, of course. You can associate all these information that are attached, that are part of the proof, actually, with a wallet address if you want to verify this on chain. Or if you're a Web2 application, you can attach this to a UUID, which is a standard for user identifiers. Great. So the current coverage, here is the current coverage of Self. You can directly go on map.self.xyz. So the complexity behind the project is that identity document like passport, IDs, Aadhaar, which is a local ID solution in India, they don't use the same signature algorithm and hash function, meaning that we had to do most of this implementation ourselves. But now most of the job is fortunately done. So you can check the current support on map.self.xyz. And also, if you're curious about what is your country using as a signature algorithm, you can just hover the country and you will have the details about that. All right, so we started by supporting biometric passport, but for HCC, we plan to release the support of biometric IDs, like the EU ID cards, but you also have some other countries that are outside of EU that are still using biometric IDs, like Saudi Arabia, for example, but many more, of course. So if you are curious, just try to scan your ID using Self and you will see if there is a chip inside. For now, to scan it and to register into Self, you need a chip, but most of all, you need a digital signature that you can verify inside the ZK proof. So if there is a signature, you can use Self with it. All right, and if you don't have a biometric passport or biometric ID, then I'm going to show you, but it's extremely simple to generate a mock one to build on top of Self. Of course, you won't be able to use that one to visit other countries. All right, so what does the experience look like and how does it work? Well, the flow is into time. I'm not going to linger on that because it's extremely related to cryptographic gadget that we are using to make you fully anonymous. But first, you need to register. And to do so, in my case, I'm going to scan my biometric passport using the NFC reader of the phone. And once it's done, it means that the digital signature is onboarded inside the mobile device. And you can start generating the first zero-knowledge proof about you. So here is the flow. We try to keep this quite short, but according to the signature algorithm used by your country, it can be, I think, up to 1 minute. All right, and when it's done, so yeah, just remember that at this step so far, you don't reveal anything about you. You just prove that you own a valid attestation, and that's it. And in the second time, you have the disclosure proof, and that's pretty much what you should be interested in. So in this one, the flow is the following. Users are going to scan a QR code or click on a button to open the Self app. And by doing so, it's going to be prompted on screen what are the information that this application is requesting them to disclose. And then they can just click on confirm. Of course, they have to acknowledge it, and then they can confirm this. And it's going to generate the ZK proof on the background and send it, share it, and this proof can be relayed directly on chain. So you don't even have to think about gas fees. Our infra can relay it, or can be sent in case of a Web2 app to a backend server. All right, so if your application is desktop based, then you are going to generate a QR code using our SDK. And if it's another mobile application, then you can just generate a deep link using our mobile SDK. You create a button, open Self, people click on the button, and tack, you will see the screen. All right, so here is the global architecture, such that you know. So people scan the passport or the biometric ID. It's stored inside your keychain. So we don't see the passport data. We don't store the passport data, obviously, because it's like the main idea of the protocol is to be privacy preserving. So we don't do such things. Everything is stored inside the mobile application. And we used to do client-side proving before, but because the current state of the art of ZK proving is what it is, we decided to offer the proving inside TEs, which are black box. So the mobile application is going to connect to the TE, which emit an attestation, and inside this attestation, you have a hash of the code who's running inside. So this way that the mobile application is going to know that this service can't do anything else besides generate the ZK proof and remove the passport data. And that's it. And finally, these the T is going to send it back to our infra, but this time the proof, not the passport data, which are going to be relayed on chain or off chain, as said before. So let's take a look at the bounties, because we are sponsoring this hackathon and we have a total of 10K in bounties. It's split in two categories, the on-chain integrations and the best off-chain integrations. And for the best on-chain integration, we have a total pool price of 9K, with 5K for the first one, 2.5 for the second one, and 1.5 for the third one. And for the best off-chain integration, which is a bit easier, of course, we have 1K, which is already pretty good. All right, I think that it's time to start learning directly by doing. And for that, let's do it together. We created a repo for this workshop. You can go directly on Self XYZ organization on GitHub and look for the workshop repo, and you just have to clone it. So the structure of the repo is in two parts. You have the app folder and the contracts folder. In the app folder, you have a Next.js application, because if you remember well, you can verify the proofs either off-chain or on-chain. So in the Next.js application, you will have the front-end parts, which allows people to scan the QR codes, but you will also have the backend, which can verify the proofs. In the contract repo, you will have all the scripts needed and boilerplates to deploy a smart contract to verify the proofs directly on-chain. So in any case, you will have to run the app repo. And then if you want to verify you will see how to do it exactly, but in the front-end part, you are going to set up the endpoints, and it's there that you are going to choose, hey, I want this proof to get verified on a smart contract, or I want this one to get verified on a backend server. All right, so let's do it. So I clone the repo here. The first step is obviously to init the submodules. So what you can do for that is just cd app, then install Do the same in the contract repo, cd contracts, bun install. So I'm using bun, but you can use yarn or npm too. I think that anything is valid here. Then you want to run the next JS application, and to do so you can just do bun run dev, and then if you go to localhost 3000, you are going to see this beautiful front-end page, and oh, the QR code is loading. It's loading because actually for the front-end SDK you need to set up an endpoint, and this endpoint, it has to be either a smart contract address if you want to verify the proof on chain, but if you want to verify the proof off chain, then it has to be a public endpoint. So let's create this public endpoint because it's not going to work with localhost 3000. So personally, to create public endpoints, I use ngrok. It's super convenient. You can do the same. Ngrok http 3000, and here it is. And then if I go to my .env, I can just replace with what was commented here. And if we reload the page, the QR code is here. Now you need to scan this QR code. You can just try to scan it. It's going to ask you to download the self application if you don't have it already yet. If you do have it, then you're done. Still, I would like to show you something. In case you don't own a biometric passport or biometric ID, let's see together how we can generate a mock one. So here is the first screen, and if you tap 5 times here, you have the developer mode. So then you can choose your new identity. Today I feel Belgian, so I'm going to cherry pick that. And then you are going to generate these mock identity documents with like a real signature behind that you can generate ZK proof with. So here is the next screen, and once it's done, it's going to start to generate the ZK proof. So as I said before, we try to keep these quite short. You can see that it's verified. Perfect. All right, and then I'm ready to go. This is the home screen, and from there you can scan the QR code. You know if the mobile application is connected if this little LED element turned green. And if that's the case, you will see prompted here all the information that this app is asking me to disclose. So for now, it's not asking me to disclose anything, but let's change that. So we can go to page.tsx. All right, and if we go here, we can modify the different disclosure attributes. So if I uncomment this line, if I do this, and then I go here and refresh the QR codes, and I scan it again, now I'm going to see that this app is asking me to disclose that I am over 15 and that I am not a citizen from North Korea, which is what we were expecting. You can also ask people to disclose information directly. So if you put true on the name, or true, let's put true on the issuing states, and on the date of birth. Then if you go back here, you refresh the page, you scan it again, you will see that now it's asking me to disclose all these different fields. So let's get this proof verified. Just hold to prove. This one is way faster than the first one, and we're still going to optimize it. All right. And that's it. Identity is verified. Yay. All right, so now let's tweak a bit more the different parameters that we can have in the backend. So if you go in routes.ts, which is in app API verify, you will see here the different the verification config. So what we can do is do a proof that is not going to work just for fun. So we can add in the excluded countries dot Belgium, because I have a Belgian passport, or Mock one I would say. So let's do it and try to verify again the proof. All right, how to verify? The proof is generating, and wow, this one got refused. So I got the error displayed on screen, invalid forbidden country lists. Oh, this is because actually this is another issue which is quite interesting. It's because in the front ends, in the app one, yeah, exactly, that's why. It's because whatever you have in the front end, you need to have the exact same thing in the back end. That's super important. So if you ask someone to prove that he's not part from a specific country list, you need to ask him, like if you want to verify that, you need to ask him to prove it first. So let's get back into it. Scan the QR codes, generate the proof. And this proof got refused, of course. And this one is a bit different. This one means that actually the proof failed to get generated because the assertion that you are not part of the country list is happening inside the zero knowledge circuit. So that's why this error code is quite different. All right, I think you can at this point just put on pause this video and just check out the documentation and see all the different disclosure attributes that you can play around with. Because in the front end, I disclosed like my issuer country I could play around with in the back end. So maybe we can try to print it. Or maybe let's directly move to the smart contract part. We have a lot of stuff to do there. All right, so just a few things before we move to the smart contract verification. So inside the QR code SDK, there are a bunch of parameters outside of the disclosure attributes that you need to take a look at. So the version you can just put to, that's the latest one. For the app name, that's what's going to be displayed inside the mobile app when you scan it. The scope is something that is going to be unique for each application. So whatever you put is going to get hashed again with the smart contract address or the DNS. So for this one, you can just put self workshop is going to be good enough. The endpoint, that's what we set up inside the .env. This one has to be a public one. If you want to verify the proof on chain, that's where you are going to put the contract address. Then you have the logo base64. So actually you should put URL to a PNG. That's recommended instead of, but putting the base64 of the logo will still work, but I would avoid doing so still. Then you can put the user ID. So the user ID for here, we put the zero address, but you can put something else if you want. We actually accept both Ethereum address or UUID. If you want to use Ethereum address, then put hex as the user ID type. And if you want to have a UUID, which is quite the norm for Web2, you can put UUID here. but let's keep it as X. All right, for the endpoint type, okay, so this one is quite important. So if you are using a mock passport, you want to use the staging environment. So the endpoint type is going to start with staging. And then if you want to verify the proof on the backend server, you are going to put HTTPS. And if you want to verify it on chain, then you can put staging cello instead. I think you can see the typing here. Oh, it's, yeah, you have these possibilities. So staging cello or cello HTTPS or staging HTTPS. So if you are hacking with a real passport or real ID card, then put just HTTPS or cello instead. All right, and then for the disclosure attribute, so you can take a look at the documentation to see all what you can disclose, but what you can understand is that you have two different kind of features. You have what you can ask the ZK proof to verify directly, like the fact that the person is above a certain age, the fact that the person is not part of the OFAC sanction list, or that the person is not part of a country list. And then you have like what you want to ask the person to reveal. And for this one, you will need to perform the logic yourself inside the backend. So in our case, in root.ts, so here, that's how I can get back the attributes. So all right, I could do something like filter subject dot expiry date, and then like play around with the information from users' credentials. But you need to implement your own logic with that. All right, so I think that now we are ready to switch to the smart contract verification. So for this one, as we said before, you can go in the smart contract repo, just hit run install, and then you have to go in the .env and set up the different parameters. So what you have is the private key of your wallet on Celo, the Celo scan API key, which is just Ethereum. I think it's just the traditional Ether scan v2 API key. Then you have to put the identity verification hub. So it's already inside. So this is the one for Celo testnets. If you are hacking on Celo mainnet, then you can just check the documentation to have the smart contract address. And finally, you need to put a verification config ID. So there is the default one, and the default one don't check anything. And this verification config ID, it's the same thing as what you did in the backend here. So that's the same thing as that, you know, where you can put excluded country and minimum age, or that's older than, and the OFAC check. All right. Once it's done, what you can do is run deploy, and it's going to deploy the smart contract. The smart contract is here. If you go in proof-of-human.sol, you can see the code of the smart contract. It's implementing the self-verification route. That's a boilerplate that you can reuse, but if you want to do something that is more custom, you just have to implement our smart contract SDK and our smart contract SDK and inherit the self-verification route class. All right. Then inside the constructor, inside the self-verification route constructor, what you need to put is the hub address. So that's why we put it inside the .env, and also you need to init the scope. So the value of the scope, if you check the deploy scripts, so we put one, that's a mock scope here, but if you go to tools.self.xyz, which is going to be your best friend for this hackathon, I hope so actually, you will have a tool to generate the scope. So here what you want to do is put the smart contract address and put the scope seeds. So if we get back to here, we have the contract address. All right, so let's put it here. And for the scope seed is what you put in the .env of the app repo. So this is the scope seed. All right, so you just have to copy paste it, and then you will have the final scope. All right, so what's the idea behind is when people are going to generate a proof, they're actually going to generate a new identity for this proof, such that if I generate a proof for app A and another one for app B, nobody can actually link these two proofs together. So if for the first one I disclose that I'm above 18 years old, and for the second one that I'm not part of the OFAC list, nobody will be able to link all this stuff, like all these proofs together, and kind of assemble all these pieces of the puzzle to know who I am. And to do so, you hash your identity with the DNS and the scope seed inside you do this inside the ZK proof. And this is to make sure that your proof is going to get consumed by this application only. So that's why when you scan the QR code, you actually see the endpoints on the mobile application, and you can see the contract address where the proof is going to get consumed, or the DNS where the proof is going to get sent. And on the smart contract side, or on the backend side, you want to make sure that this proof was really targeting your smart contract or your backend. So that's why you want to put that. All right, so you just have to copy the scope, then you can go into setscope.js, and replace the new scope with the value, and then you can just do burn run set scope, and it's going to update the scope on chain. All right, so we can see that it's using, can we see the contract address by the way here? Using the contract at, is it the same one? Yes, it's the same one. All right, perfect. So now the scope is set. The verification config ID is set to, oh, by the way, if you want to change this one, once again, you will need to go to the developer tools, and you can directly here, you just have to modify the verification config and click on this button, and it's going to give you, it's going to send the transaction to the hub and give you back the value of the verification config that you want to use. All right, so let's get back to it. So my verification config is set, my scope is set, I'm already ready for the verification. So I'm going to take the contract address, go inside the .env of my app repo, and change the endpoint for the smart contract address. All right. And then, so for the public scope, we keep the same. And then, all right, this is the thing. Here, you need to update it for cello or staging cello. All right. Let's get back to our front ends, scan the QR codes. We generate the proof. The proof is generating. It's going to take a bit more time, this one, because you also need to wait for the on-chain verification of the proof. And it's done. So let's go to Celoscan. Do we have it here? Farojes. All right. Verify self-proof. So this is my transaction that happened 20 seconds before. Yeah, that's pretty much it. So now what I can do is read the contract just for fun. So here, let's not mind about this function. So you can see again the value of your scope. You can see the value again of the verification config that is settled, the verification config value, like the ID. And then what's fun is you can get the last output. So this is by design of this boilerplate, but if I go here, I will see the value of the different fields. So we are going to change this right now. So there is attestation ID. This one is 2. It means that I used a mock ID cards. If it's 1, it's for the biometric passport. Then what do we have? The user identifier, the nullifier, the ID number, nationality, date of birth, gender. All right. But if we do change stuff, like here, we ask the person to disclose, let's say, the gender, and let's say the nationality. Yeah, and of course put it to true. Alright, so the proof got verified again. But this time, if you query, you can see that the nationality got disclosed with BEL, which is the country 3 alpha code for Belgium. And you also have the gender. And that's a boy. Cool. What else can we check inside the smart contract that could be interesting? Or maybe you probably want to use the address inside the smart contract. Do we have last used address? Or it's in the reset already? Oh. Oh, there is last used address, I see here. So, last used address, it's the 0 address. It's the 0 address, but if we put something different here, like let's go to vanity address, let's generate one, let's do something cool like self. Wait, this is totally not mandatory, of course, but alright, let's take this address just because it's a bit fun. Then I can go back to page.tsx, and for the user address, instead of the Ethereum 0 address, I can put my vanity address, which is starting by self and then a 0. Wow, that's how cool is that? Yeah, I just have to do that. I go back to my front ends, I scan it again.